In this video, we're going to solve exponential equations. Here's a property. If b is a number greater than 0 and not equal to 1, and m and n are real numbers, if we say b to the n equals b to the m, this is only true if and only if n equals m. The exponents would have to be equal. If the bases are the same, the exponents would have to be equal as well. So to solve an exponential equation, you're actually just trying to solve for x like you normally do in any equation. But in this case, we have 2 to the power of x equal to 16. So what you need to do is try to write the equation where you have two identical bases. For example, 2 to the x, I can't really change that, but I know that 16 is 2 to the 4th power. So since I could write 16 as a power of 2, since my bases are equal here, 2 and 2, the exponents are equal. X equals 4. Solves that equation. Here's another. 729 equals 9 to the 3x. So I'm going to see if I can find a power of 9 that would equal 729. Using a calculator, I know 9 squared is 81, but 9 to the 3rd power makes me think it is. 9 to the 3rd is actually 729. Now, I just played around with my calculator to figure out a common base that I could use in this problem. So since 9 is the common base, the exponents are equal. 3 equals 3x. To solve this equation, I would just divide both sides by 3. So the solution, x equals 1. Three to the negative x power equals 1 over 27. Now we know that a negative exponent will flip an expression. So instead of writing 3 to the negative x, I'm going to rewrite that using my exponent property. That is 1 over 3 to the positive x, which equals 1 over 27. So in this problem, since the 1's equal, so I don't have to worry about that, 3 to the x equals 27. So let's go over and work a simpler equation. 3 to the power of x is equal to 27. 27 is 3 to the 3rd power. So the exponents are equal. X would equal 3. Six to the power of 3x minus 1 equals 36. So 6 to the 3x minus 1 equals 36 to be written as a power of 6. So 6 to the 2nd power. Therefore, my equation, since the bases are equal, will be 3x minus 1 equal to 2. To solve that equation, I'll just add 1 to both sides. 3x equals 3, divide by 3. So the solution is x equal to 1. (27 to the 4x equals 9 to the x plus 1). Now, 27 can never be written as a power of 9, nor could 9 ever be 27. So we need to use a common base that both of those numbers would fit with. And it just so happens they could both be written as powers of 3. So instead of 27, I'm going to rewrite that as 3 to the 3rd to the 4x. And the 9 we're going to replace as 3 squared to the x plus 1. Now, if you remember from earlier algebra courses, when you have a power inside parentheses raised to a power outside, you use multiplication to simplify. So this would actually equal on the left side 3 to the 3 times 4x, which would be 12x, equal to 3 to the 2 times x plus 1. I'll need to multiply those with the distributive property, 2x plus 2. Notice now I have like bases, so I can equate the exponents. So 12x equals 2x plus 2. To solve this equation, I'm going to subtract 2x from both sides. That leaves me 10x equal to 2. Divide both sides by 10. 2/10 can reduce to 1/5. Nine to the 4x minus 2 equals 1 over 81. I think I can use 9. So 9 to the 4x minus 2 equals 1 over 81. Actually, 9 squared is 81. But since it's been flipped, we know that that means the exponent would have been negative 2. So my equation, since my bases are equal, 4x minus 2 equals minus 2. So I'm going to add 2 to both sides. 4x equals 0. Divide by 4. So x would equal 0 for the solution to this equation. One last problem. X to the 3/2 power equals 27. If I want to solve for x, what I need to do is find x to the first power. We know that we can get rid of a fraction, change a fraction to 1 by multiplying by its reciprocal. So what I need to do is raise both sides to the power of its reciprocal. So if I have x to the 3/2, if I raise that to the 2/3 and raise 27 to the 2/3 as well, I should be able to solve. Notice when I multiply the exponents, 2 cancels with 2 and 3 cancels with the 3. So I would be left x equals 27 to the 2/3 power. Now, from your intermediate algebra days, if you remember, when you have a fractional exponent, the denominator is the root and the numerator is the exponent. So what we'll do first is take the cube root of 27. And then we will square the answer. Okay? Cube root and then the exponent. So x is equal to, the cube root of 27 we know is 3, and then that's squared, so x is equal to 9. We could plug that answer in and check that into your original equation. 9 to the 3/2, the square root of 9 is 3, and then 3 to the 3rd would give us 27.